Alright, example 6 is very, very similar to example 5, except we're not going to be dealing with decimals, thank goodness. So what we are given is that our sine is equal to a 1/4. So if your sine of theta is equal to a 1/4, that is the same thing as saying that is your opposite side over your hypotenuse. So if you draw a triangle here, I'm going to draw another one here in the first quadrant, up, over, and we're going to say that this is our theta here. Your opposite side is a 1, your hypotenuse is a 4. In order to find out what our cosecant is, actually we don't even need our triangle here, because if your sine is a 1/4, that means that your cosecant is going to end up being a 4. It's just the reciprocal. So you find the reciprocal of your sine, you get cosecant theta. Now we are going to need the rest of this triangle to help us find the cotangent, because our cotangent is just a 1 over tangent theta. And that means we're going to have an x over a y. So we're going to take our, what was going to be called our, sorry, let me back up here. If this is the inverse of your tangent, so if you have TOA, then, and tangent is opposite over adjacent, that means cotangent is going to be your adjacent side over your opposite. There we go. So what we need to do is we need to figure out our adjacent side right here. We don't know what that is, so if we let this be our x, we're going to set x squared plus a 1 squared equals 4 squared, right? 4 is our hypotenuse, it's always your longest side. So you plug these in here, you get x squared plus 1 equals 16. So you need to subtract 1 on both sides, get 15, square root both sides, you get radical 15. So x is radical 15. This is also your adjacent side, and 1 is going to be your opposite side. So if we're looking for our adjacent over our opposite, we're going to say that is radical 15 over 1, or just radical 15. So the big thing is know how to draw your triangles. So if you need help drawing a shape with 3 sides, let me know. Or let somebody else know that knows how to draw pretty triangles.